Hey there. So we're going to talk a little bit about binomial theorem today. So what is a binomial theorem? So before talking about binomial theorem, let me give you a quick introduction. So here we're going to talk about an algebraic expression which is going to consist of two terms. So an algebraic expression that contains two terms is referred to as a binomial expression. A binomial expression. For example, if we consider a plus b, then twice x minus thrice of y, x plus 1 over y, x plus 3 over x, 2 over x, minus 1 over x squared, etc. These are all different forms of binomial expression. So if we are to have an algebraic expression with three terms, let's include a third variable c. Maybe c twice x minus thrice of y plus 4 of z, x plus 1 over y plus 2 of z, etc. So these contains three terms, so we're going to call it a trinomial expression. Trinomial expression. Okay, so that's it. And any other algebraic expression that is going to have more than three terms will be referred to as a multinomial expression. Okay. Now let's talk about the general form of a binomial expression. General form of a binomial expression. So, given a binomial expression, x plus a, then the expansion of x plus a whole raised to the power n, where n belongs to a set of natural numbers, is called a binomial, is called the binomial theorem. Okay. So this theorem was first given by Newton and gives the formula for the expansion of the powers of a binomial expression. So let me give you a quick example what binomial expansion truly means. So given the binomial expression, if it's raised to the power of 0, we get 1. X plus a whole raised to the power 1 gives us x plus a. So here we have one term. For the first expression, the binomial expansion of x plus a raised to the power 0 gives us one term. The binomial expansion of x plus a raised to the power 1 gives us two terms. X plus a whole raised to the power 2, this is 1, whole raised to the power 2. If you remember, this is an identity, so this is x squared plus twice x times a plus a squared. So this is going to have three terms. Then x plus a whole raised to the power 3, when we expand it, we're going to get x cubed plus 3 x squared times a plus 3 x times a squared plus a cubed. So this is going to have four terms. And so on, we can find out the expansion of x plus a raised to the power 4 simply by using either x plus a whole squared times x plus a whole squared, or you can do x plus a times x plus a whole cube. So we use the above, use the expansion from the above to above four results. Any of the four results? Not any of the four. I mean, yeah. Excuse me. Sorry about it. What I mean to say is, like, if you want to find out the algebraic expression of x plus a raised to the power 4, what you can do is you can take the result of x plus a whole squared and then multiply it to itself, then we'll get the result. We'll get the expansion for x plus a whole raised to the power 4. So what we can do, what we have done, we can summarize this something like this. So the index, so I'm going to tabulate whatever I've just written down. Here I'm writing the index of the binomial. So index is going to be the power of the binomial expansion. So 0, 1, 2, 3, and 4. So we're going to consider 5 indexes. And on the next column, so we tabulate this. So in the next section will be the coefficient of various terms. So the first index was 0. So if we consider 0, so the coefficient of various terms, so there were only one term. So there was only one term and the coefficient was 1. So we're going to write here 1. For the next one, which is 1, then we got two terms, which was x and a. The coefficient of x is 1 and the coefficient of a is 1. So we'll write it down separately as 1, 1. Similarly, if we fill up for 2, then we got x squared 2ax and the a squared. Similarly for 3, we got x squared and 3x squared times a, 3x times a squared, and a cubed. So what we observe here, that each row is bounded by 1 on both sides. And in the entry, except the first and the last in the row, is the sum of the two entries in the preceding law. So you can see, if you consider this 1 and 1, when you add it, then you're going to get 2. Here, you add 1 and 2, you'll get 3. 2 gets added to 1 to get 3. So what we can do is, like, we can form a triangle. Let's do it. So we're going to get first, for index 0, we got coefficient 1. For index 2, for index 1, we got coefficient 1 and 1. for index 2. We don't have to remember, so what do we write? We only write the 1 on both sides. And we're going to add this 1 and this 1 together to get 2. Then the next step, what we're going to do is we're going to add this 1 and 2 to get 3, 2 and 1 to get a 3. 1, 1, set. Then 1 plus 3 gives us 4, 3 plus 3 gives us 6, and 3 plus 1 gives us 4. Then 1 and 1, and we're going to add 1 and 4, and which is, excuse me, we're going to add 1 and 1, so this is going to give us 1 plus 4 as 5, 4 and 6 adds up to 10, 6 and 4 adds up to 10, and 4 and 1 adds up to 5. Let me draw the final one. So 1 on both sides, then we add 1 and 5 to get 6, 5 and 10, 15, 10 and 10, 20, 10 and 5 is 15, and 5 and 1 gives us 6. So this is what is called Pascal's triangle. So yep, so this is the Pascal's triangle. Now what we're going to do, we are going to use this Pascal's triangle. We're going to rebuild the Pascal's triangle with the help of coefficients. So let me copy this and okay, cool. We'll squeeze it a little bit. Great. Now, if you remember how to calculate combinations, then 1 can be written as NC0, or you can say 1C0. So I'll write here 1C0, because if you calculate 1C0, then you get 1. Quickly, a quick recap, if you forgot how to calculate combinations, then the formula for calculating combinations is NCR equals n factorial over r factorial times n minus r factorial. So if I have to calculate NC0, and this will be 1 factorial over 0 factorial times 1 minus 0 factorial, which is 1 factorial divided by 0 factorial times 1 factorial. Now 1 factorial, the value of 1 factorial is 1, and the value of 0 factorial is also 1. So if you plug these values into the fraction, then this should yield 1. Okay, so that's what I've done. Instead of writing 1, so what I've replaced 1C0. Now here 1, remember the index was 0, so the index for the first coefficient was 0, so this is how I chose 1. Yeah, my mistake. The index, yeah, the index is 0. Yeah, so if the index n is equals to 0, then we do the counting from n plus 1. So this is where 1 comes in. Next, for the binomial index n equals to 1, what we're going to do is we're going to replace 1 by 2c0. Oh, I made a terrible mistake. I'm sorry about that. So wait, I got a little confused. I got a little carried away. Okay, so yeah, let me fix this. So for the first binomial index n equals to 0, so what we're going to write, it's 0c0. So here n equals to 0, so so this will be 0c0, and 0c0 the value is 1. Now for n equals to 1, what we will write here is 1c0 and 1c1. This is for n equals to 1. For n equals to 2, what we'll have is 2. N equals to 2 will give us 2c0, 2c1 and 2c2. For n equals to 3, we'll write 3c0, 3c1, 3c2, and oops, I don't have enough space. This will be 3c3. If it is possible, let me move this formula. Okay, this will work just fine. Okay, so this will be 3c3. Okay. Now if you calculate this value, so 0c0 gives us 1, which is in accordance with the Pascal's triangle for index n equals to 0. Then you calculate the value of 1c0, which is also going to give you 1, and 1c1 is also going to give us 1. So this is in concordance with n equals to 1. So what we have done is we have taken the Pascal's triangle and converted it into converted in the sense like we are writing the coefficient in terms of combinations. So like the coefficients will be now represented by using combination. So this is also a form of a Pascal triangle, but what you have done is we have simply replaced all the constant coefficients by simply using the combinations. Right. Now what we can do is now let us combine it with the expansion that we did earlier, which was this thing, the binomial, where we were applying the binomial theorem for different positive indexes including 0. Okay, so let us rewrite it. So x plus a whole raised to the power 0 can be written as simply 1. Nothing much to be done here. So if I had to replace here 1, then we'll simply write it 0c0. Then x plus a raised to the positive index 1 should give us x plus a. Now what we're going to do is the coefficient of x is 1. Now 1, instead of writing here 1, we're going to write here 1c0. X plus 1c1 times a. Right? Then for the next index, x plus a raised to the index 2 will be, remember it was x squared plus 2xa plus a squared. Now the coefficient of x squared is 1. So we'll write here instead of 1, 2c0 times x squared plus 2. Then 2 will be, if you do the calculation, we'll find out that 2c1 is 2. So you will write x times a. And the final coefficient, the third term, which is 1, can be written as 2c2. 2c2 gives us 1. Okay, so before going further, what I'm going to do is I'm going to generalize this. So we're going to look at x plus 1 I all raised to the power 1. So we're going to generalize this. I'm going to do some adjustments here. Let's see what kind of adjustments I'm going to do. So 1c0 Now I'm going to change that. So x. So you see that x, the index of x is 1. So if I write here instead 1 minus 0 times a raised to the power 0, nothing is going to get changed here. Everything, like nothing new I have added here, nothing new. So a raised to the power 0 is 1, x raised to the power 1 minus 0. It gives us the original term. So there is nothing changes here. What I'm done here is some modification. In a very smart way, I've done this modification where instead of writing x raised to the power 1, I'm simply writing it 1 minus 0. Okay, then moving on to the next term, 1c1. So here there is no x terms. What I can do here is x 1 minus 1. Why? Because 1 subtracted from 1 gives us 0, and anything raised to the power 0 is 1. But that's fine, so we can do that. Times a raised to the power 1. If you're having a confusion here, let's try the same technique in the next one, in the expansion of x plus a whole squared. So for the first time, 2c0 remains unchanged, x squared. So what I'm going to do here is subtract a 0 from it. There is no a term here, but what I'm going to do is multiply with a raised to the power 0. Okay. Instead of 2c1, I'm going to write here, no, 2c1 will stay the same, so it's 2c1x. So the index of x is 1, but instead I'm going to write here 2 minus 1. And for a, there is no change here. A stays as a, index of 1. Plus for the third term 2c2. So there's no x here, but I'm going to write here instead x 2 minus 2 times a squared. So if I were to look at expression number 1, express the expansion of 1 and expression 2, then we can write a general form of x plus a whole raised to the power some positive integer n. Then this could be written as nc0 x times n minus 0 times a raised to the power 0 plus nc1 x raised to the power n minus 1 a raised to the power 1 plus dot dot dot. The last term will be ncn x raised to the power n minus n times a raised to the power n. I'm pretty sure you're getting a hang of it right now. So this entire binomial expansion, this is the binomial expansion, the general binomial expansion of ax plus a whole raised to the power n. So there's a summation appearing. So what we can do, we can squeeze it and write in a summation form as sigma r equals to 0 and runs up to n. This will be ncr x raised to the power n minus r times a raised to the power r. So this is called the binomial expansion of x plus a whole raised to the power n. So I'm going to write here, this is our binomial expansion of x plus a, of the algebraic expression x plus a for some positive integral index. Mean n is an integer and it is positive, so some positive integer n. So the binomial expression, the binomial expansion of x plus a is given by this formulae. Okay, so let's use this expansion. Let's understand how this expansion was used to solve some particular type of questions. So let me take a snap of this particular equation and to the top of the page. Okay, great. So this is a binomial theorem. Now let's take an example. So we have to expand twice of x minus thrice of y whole raised to the power 9. So it's very simple. Let's do that step by step. So use a different color. So this is NC0, 9C0. So n is 9 here. So this will be 9C0. So x. So here x is actually twice of x. This twice of x so we're considering that x is actually twice of x here and a is negative thrice of y. And we're going to replace this into our formulae. So what we should get is twice x. This should be 9 minus 0 times minus thrice of y whole raised to the power 0 plus 9c1 plus 9c1 twice of x 9 minus 1 times minus of 3y raised to the power of 1. I'm running out of space. That's okay. Plus 9c2 twice of x raised to the power 9 minus 2 times negative 3y all raised to the power 2 plus 9c3 twice x raised to the power 9 minus 3. So this is n minus r. So n is 9 here and r is 3. So we're on the fourth term, first term, second term, third term, and this is our fourth term. So this is twice x raised to the power 9 minus 3 times minus of 3y raised to the power 3 plus 9c4 2x raised to the power 9 minus 4 times negative 3y raised to the power 4 plus 9c5. We have to go till r is 5. So it's a very long way to go. Let's do it slowly and steadily. 9 minus 5 times negative 3y whole raised to the power 5 plus 9c6 twice x raised to the power 9 minus 6 times negative 3y raised to the power 6 plus 9c7 twice x raised to the power 9 minus 7 times negative 3y raised to the power 7 plus 9c8 2x raised to the power 9 minus 8 times negative 3y raised to the power 8. And the final term will be 9c9 2x raised to the power 9 minus 9 times negative 3y raised to the power of 9. What we have to do is compute each of the terms. So 9c0, so what you can do is you can use a calculator or you can use the formula that NCR is equals to 9 factorial over r factorial times n minus r factorial. What I'm going to do is I'm going to use my scientific calculator to quickly find the value of all the coefficients 9c0. So 9c0, this is very easy. 9c0 is always 1, and 2x to the power 9. So what we can do is we can write here. Let me make it a little smaller. Okay, looks good. So this would be 9c0 is 1 times 2x whole raised to the power 9. Then we have negative 3y raised to the power 0, which is always 1. Anything raised to the power 0 is considered 1. Plus 9c1. If you use a calculator, the 9c1 gives us 9 times 2x raised to the power 9 minus 1 is 8. And this will be simply negative 3y plus 9c2. Let me check what is 9c2. Where is my combination calculator? Yeah, got it. So 9c2. So 9c2 is 36. Perfect. So this is 36 times 2x raised to the power 9 minus 2 is 7, and negative 3y whole squared, so this is going to be positive of 9y squared. Fine. Then the fourth term will be 9c3, so 9c3 is 84, so 84 twice x whole thing raised to the power, what was it, 1 2 3 4 in the fourth term, so 9 minus 3 is 6, and we have negative 3y cubed, so which is 27y cubed, plus 9c4, so 9c4 is 126 times 2x raised to the power 5, and so this is negative 3 raised to the power 4. Negative 3 raised to the power 4 is 81. Y raised to the power of 4. Okay, the next one is 9c5. So 9c5 is 126. So y is 126. 2x raised to the power of 4. So now what I'm going to implicate, this is a very big number, negative 3y. So what is negative 3 raised to the power 5? Negative 3 whole raised to the power of 5 is negative 243. Negative 243 y raised to the power of 5, plus, then we need to find out 9c6. 9c6 is 84. 84, and this will be twice x, whole thing raised to the power of 3, and negative 3 raised to the power of 6. Negative 3 whole raised to the power of 6 is 729. So this is positive 729 y raised to the power of 6. How many more are left? 3 more to go. Okay. Phew, that's quite a big number. 9c7. Okay, 9c7 should give us 36. Yes, 36 twice x whole thing raised to the power of 2. And this is negative. So 2187 y raised to the power of 7 plus, then we have 9c8. 9c8 is 9. 9c8 is 9 twice of x raised to the power 1, and this is 3 raised to the power of 8. 3 raised to the power 8 is 6561. 6561 y raised to the power of 8 plus 9c9 is 1. This is 1. 2x whole thing raised to the power 0 times negative 3 whole thing raised to the power of 9. It's negative 19,683 y raised to the power of 9. Okay, so we come to the final part of the calculation. So this is the expansion of twice x minus 3 of y whole raised to the power 9. So this gives us 2 raised to the power 9. Okay, 2 raised to the power 9 is 512. 512 x raised to the power 9. Negative. So 9 times 2 raised to the power of 8 times 3. So this is 6912. 6912 x raised to the power 8 times y plus 36 times 2 raised to the power 7 times 9. So this is 41,472 x raised to the power 7 y squared plus 84 times 2 raised to the power of 6 times negative 27. So this gives us, okay, so this is negative, so this will give us negative 145,152 x raised to the power 6 y cubed. Then we have plus 126 times 2 raised to the power of 5 times 81. So this is 326 592 x raised to the power 5 y raised to the power 4 plus 126 times 2 raised to the power of 4 times negative 243. So this is, okay, so this is negative, so this is negative 489,888. So this is x raised to the power 4 y raised to the power 5. Then positive 84 times 2 to the power 3, which is 8, times 729. So this is 489,000. Oh, nice. 888 x cube y raised to the power of 6. And the next one should be negative, which is 36 times 4 times negative 2187. So this is 314,928 x squared y raised to the power 7 plus, then we have 9 times 2 times 6561, which is 118,098 x y raised to the power 8 negative. So this is 1 times 1 times 19,683 y raised to the power 9. We took a very difficult one. So this is the binomial expansion. Way too bigger. So this is the binomial expansion of twice x minus 3y whole raised to the power 9. Now, one more thing I'd like to state here. So the index is 9 here. So if you know the index value, then you can also tell the number of terms it will have. So number of terms is equals to n plus 1. So we have the number of terms as 9. So 9 plus 1 gives us 10. Let's see if we got 10 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. So we have 10 terms. So this is a formula, so we can quickly tell if we know whatever is the index value, just add 1 to it, and this will give us the number of terms. Let us do a simple one. Because I took a really long one. Let me take a smaller one. Okay, so we have x squared plus 2a all raised to the power 5. So what we have to do is we have to expand this binomial expansion, x squared plus 2a with the help of a binomial theorem. So we know the binomial theorem states that summation r is 0 to n. So we have 0 to 5. So we had NCR, so we're going to write here 5CR. Our AX is x squared, whole thing raised to the power 5 minus r, times a, which is 2a here, 2a raised to the power r. So what we've done here is considering x squared is equivalent to x and 2a is equivalent to a. Okay, so let us expand this. So what we should get is, let me rewrite it before opening up the summation. Now goes from 0 to 5. 5CR x. So it's power of a power. So we know that whenever it's an exponent of an exponent, the exponent simply gets multiplied. So we'll get 10 minus 2 times r is twice of r. That's it. And here I'm going to open up, so we can write here 2 raised to the power r times a raised to the power r. Great. Now we'll start opening this summation. So this is 5c0 x raised to the power 10 minus, so 2 times 0 is 0. So this is 2 raised to the power 0 and a raised to the power 0 plus 5c1 x raised to the power 10 minus, so 2 times 1 is 2, so we'll simply write here 10 minus 2, 2 raised to the power 1 times a raised to the power 1. We have space, I think there will be enough space to squeeze one more term. Okay, so this is 5c2 x raised to the power 10 minus, so 2 times 2 is 4, so 10 minus 4. This will be 2 squared and a squared. Then the fourth term, this is the fourth term, yes, 5c3. So 5c3 x raised to the power 10 minus, so 3 times 2 is 6, 10 minus 6, 2 raised to the power of 3 times a raised to the power of 3 plus 5c4 x raised to the power 10 minus 2 times 4 is 8, 10 minus 8, times 2 raised to the power of 4 a raised to the power of 4 times plus 5c5 x raised to the power 10 minus 10 times 2 raised to the power of 5 times a raised to the power of 5. Yes, so we're done now. Done with the expansion, and what we have to do is calculate the coefficients and the individual index values. So 5c0 is 1, then we have x raised to the power of 10, 2 to the power of 0 is 1, times a raised to the power of 0 is 1, so this is 1. Then 5c1 is 5, x raised to the power 10 minus 2 gives us x raised to the power of 8, then times 2 times a. So 5c2 is, what is 5c2? It's 10. 5c2 is 10. You can use a calculator to find out the value. So 5c2 is 10. 10 times x raised to the power of 6 times 2 squared is 4 times a squared. Then we come to 5c3. So 5c3 is also 10. 5c3 is 10, x raised to the power of 4, 2 raised to the power of 3 is 8, then a cube plus 5c4. So 5c4 is 5, x raised to the power of 2, 2 raised to the power of 4 is 16, and times a raised to the power of 4 plus 5c5 is 1, x raised to the is 10 to 0. Let me write it down, which will be 1. Then 2 raised to the power of 5 is 32 times e raised to the power of 5. So the final expansion would look something like raised to the power of 10. So 5 times 2 is 10. So this is 10 x raised to the power of 8 times I plus 40 x raised to the power of 60 times a squared plus 10 times 8 is 80, so x raised to the power of 4 times a cubed, then 5 times 16 is also 80, x squared a fourth plus 32 e raised to the power 5. Then we're done. So this is the binomial expansion of x squared plus 2a whole raised to the power 5. So what we've done is we've used the theorem, the binomial theorem, to find out the expansion of x squared plus 2a. Okay, so now that you've understood how to use the binomial theorem, I think now we'll be pretty much comfortable to solve different problems on your own. Let me give you one more example. Let's take a simpler one. Let's take a simpler in the sense it's going to involve some negative values. So we're going to take example number 3. So we're given the expansion twice of x minus thrice of y whole raised to the power of 4. So we have to expand using binomial theorem. First thing first, we know here that n value is 4, so our number of terms. So what will be the number of terms? Simply 4 plus 1, which is 5, so there should be 5 terms. Here we're going to represent 2x. We're going to consider 2x to be equivalent to x and negative 3y to be equivalent to positive a. Okay, so let's do that. So twice x minus 3y, 4. So this should be 4c0, which is x raised to the power, so x is our 2x here, x raised to the power 4 minus 0, it's 4, and a raised to the power of 0, so a we have considered it to be negative 3y, so negative 3y raised to the power of 0, plus 4c1, twice x raised to the power 4 minus 1 is 3, and negative 3y raised to the power of 1 plus 4c2 twice x, 4 minus 2 is 2, so this is squared, and negative 3y squared plus 4c3 twice x raised to the power of 4 minus 3 is 1, and negative 3y raised to the power of 3 plus 4c4 twice x raised to the power of 4 minus 4 is 0 times 3 was negative thrice of y raised to the power of 4. So we're pretty much done. All we have to do is expand it further. So 4c0 is 1, 2 to the power of 4 is 16, x raised to the power of 4, and negative thrice of y to the power of 0 is 1, plus 4c1 is 4, so 2 cubed is 8, so this is going to give us 8x cubed times negative 3y plus 4c2. So what is 4c2? 6. Is it? Yeah, it is 6. Then 2x squared will give us 4x squared. Negative 3y squared is simply going to give us positive 9y squared. 4c3. So what is 4c3? It's 4. So it is 4 twice x times negative 3 cubed is negative 27 y cubed. 4c4 is 1, 2x raised to the power 0 is 1, and negative 3 to the power 4 is positive 81 times y to the power 44, y to the power 4. So final expression should look like 16x raised to the power 4 negative 4 times 8 is 32, 32 times 3 is 96, 96x cubed y plus 6 times 4 is 24, and 24 times 9 is 216, x squared, y squared, negative 4 times 2 is 8, 8 times 27, 8 times 27 is 216, so 216xy cubed is 81 y raised to the power 4. So this is the binomial expansion of twice x minus 3y all raised to the power of 4. Very simple. I hope this is clear. Okay, so now what we can do is, now that we've understood how to perform binomial expansion, so let me give you some practice problems, so you can pause this video. Okay, I've run out of space here. I'm going to do, okay, this is good space. So what you can do is you can try using a binomial theorem, then you can expand the expression 1 plus x squared whole raised to the power of 3. This is question number 1, and question number 2, 1 minus x plus x squared whole raised to the power 4. How would you do that? This is very simple. There are two ways of doing this particular. So what we do, we allow x to be equivalent to 1 plus x and a to be equivalent to x squared. So this is method 1, method number 1. Oh, there's a simpler method. It's much easier for the calculation. Well, it was going to take the same amount of time. This is just a way of choice, whichever you want to do. So what you do is you allow x to be 1 and a to be x plus x squared. So you can use either method 1 or method 2 to solve 1 and 2. So let me give a quick hint. So what we're going to do is we can write here. So I'm going to use method 2 here. So 1 plus x squared whole raised to the power 3. So if we apply a binomial theorem, so this becomes r goes from 0 to 3, 3c0, 1 raised to the power 3 minus 0, which is 3, and this is x plus x squared to the power r. So 3cr, oh, this is 3cr, so this is 3 minus r. Now you know that 1, it doesn't matter the first value, 1 raised to the power 3 minus 1 is always going to be 1. So this gets simplified to 3cr x plus x squared raised to the power r. So you can expand the summation, and then you will get the result for 1 plus x squared all raised to the power of 3. So that's it. So this is all about binomial expansion, and we'll come again and pick up some more exercises, and we'll do lots of problems. So in the meantime, you can try this out, and in the next lecture I'm going to pick those two particular questions and solve them, and you can match your answers with mine, and it was the same. Great. And let me know in the comment section how you found the lecture.